Alright guys, welcome to this page of the notes. What we're going to do now is we're going to take those terms and definitions as well as that arc addition postulate we just learned and use those to help us solve some problems. Remember, the way this works, we apply a little bit of geometry and then wind up essentially doing algebra. So let's see how geometry and algebra are going to go together in these ones. Alright, here's the way that these are going to work. I have given you a nice little diagram. Please notice that there are circles. We've got a whole bunch of stuff going on in here. I have several central angles. I even give you some information about some arcs. So let's see what we've got. We'll jump right into this by first noticing that I tell you the angle of BCD is 18 degrees. Let's find BCD. BCD is this guy right here, BCD. And I tell you that the measure of that is 18 degrees. Fantastic, 18 degrees. That is the measure of that angle. Okay, here we go. Then I tell you that the measure, careful, please notice, arc. So the measure of arc EF is 33 degrees. Here is arc EF right there. And I tell you that the measure of that arc is 33 degrees. Okay, now a couple of really important things to point out to you here. First, please notice that I have two different circles. I have a smaller circle right here, and then I have a larger circle out here. Okay. Interesting note about this. When it comes to circles, okay, the size of the circle, okay, the size of the circle does not determine, okay, actually here, let me say it this way. Hopefully what you'll notice, let me use a good color. Actually for the moment here, let me erase that blue stuff, this one right here. Alright, so we've already talked about the measure of angle BCD. We know that that's 18 degrees. Right now I want to use this blue marker to copy, trace over these two lines right there and right there. A really important note, something that we've seen before. Anytime you have two intersecting lines, you will always create two pairs of vertical angles. That's right, here they are again. We learned about vertical angles back in chapter 4. They have shown up in every single chapter since then. Here we are in what, chapter 15? I mean, vertical angles, really, really important idea. And here they are. I have vertical angles once again. However, you say to me, wait a second, Mr. Lauren, it's EF. It's an arc. Okay, fantastic. So here's the idea. Remember, a full circle, one full rotation is 360 degrees. So I've got this smaller red circle, right? This smaller red circle, and arc EF is 33 of that 360 degrees. So 33 degrees of the 360 is arc EF. Okay, so I take that smaller circle, let's expand it out to the bigger green circle. How far is it around the outside of the green circle? It's still 360 degrees. It doesn't matter that I made the circle bigger. It's still a 360 degrees to go all the way around the outside of that circle. So even though the red circle is smaller, right? Arc EF is 33 degrees. I make that circle bigger. It does not change the fact that arc AB will have the exact same measure as arc EF. They're both going to be 33 degrees. Even though they're not on the same circle, they both sweep out, they both cover the same portion of their respective circle. Sure, this one's a little bit smaller, so EF is closer together. The green circle's a little bit bigger, so that spreads AB out a little bit further, but it doesn't change the fact that EF is 33 degrees of its 360 degree circle, and AB is 33 degrees of its 360-degree circle. They're just different sized circles. One circle's a little smaller, the other circle's drawn a little bit bigger. The only difference between the red and the green circle is the length of the radius, right? That's the only difference. Okay, so the vertical angle theorem is still going to apply even if we're talking about arcs, because they are opposite, they're vertical angles of each other, the arc lengths are also going to be equivalent. So, really, really important. This means that the measure of arc EF is congruent to the measure of arc AB, irrespective of the size of the circle. If they are vertical angles, vertical arcs, then they're going to have the same measure. Well, that's it. That's all we needed, right? I'm asking you to determine the measure of arc ABD. The measure of arc ABD. Well, ABD. I know that BCD is 18. I now know that AB is 33. So this is the arc addition postulate. The measure of arc ABD is going to be equal to the measure of arc AB plus the measure of arc BD. So, arc addition postulate, add them up. I know AB is 33 degrees because it's equivalent to EF, and I know that BD is 18 because I gave that to me in the problem. We add those guys together and you should get 51 degrees. All right, and that's the way that these problems are going to go. We're using the arc addition postulate as well as a theorem from previous chapters. All that stuff's going to keep following us all the way through geometry to help us solve a problem. Let's go and do another one. Here we go. Let's see if you can work your way through this one. Let's see what we got here. First, they tell me that the measure of arc JK is 27. Let's find JK. There it is right here. Here's JK. Boom. This guy, this arc is 27 degrees. That's the measure of the arc. So check it out. Please notice JK is going to be a vertical arc with MN. So that means I now know that MN is also 27 degrees. Again, this is going to be vertical arcs, which means that the measure of arc JK is congruent to the measure of arc MN, which means since JK was 27, arc MN is also 27. Okay, let's see. Determine NP. I want you to find arc NP. Let's go ahead and put NP. I'm looking for this guy right here. Ooh, interesting. Look at this. Please notice that MK, this guy right here, is a diameter, right? How do you know it's a, well, no, look, I put that little 90-degree symbol in there, right? 90-degree symbol. Well, look, that means then that MNP is also 90 degrees, right? If this is a straight line, right? If that's a straight line, if this is 90, then that's got to be 90. So here's what we've got. I know that the measure of MNP is equal to the measure of arc MN plus the measure of arc NP. Right, I have to sum together MN and NP, right? Add those two together, that'll give me MNP, that whole thing. Right, but I'm looking for NP. All right, well, here we go. I already figured out MN. I know MN is a vertical arc with JK, so that's easy. What is MNP? Well, MNP, because this one is 90 degrees, that means that MNP also has to be 90 degrees. So I know that this guy is 90 degrees. That's equal to 27 degrees. Again, it's the arc addition postulate, but in this case, instead of solving for the larger arc, I'm trying to find just the little piece NP. How do I do that? Subtract the 27 to the other side. So the measure of arc NP is going to be equal to 90 minus 27. And we wind up getting 63 degrees. 63 degrees. Okay, I got one more problem for us here. Let's do one dealing with clocks. Why? Well, because the face of a clock, of course, is a circle. It's 360 degrees, and let's see what happens. I give you a time of 3:10. I want to know the minute hand, right? Clock sweeps out an arc as time moves forward from 3:10 to 3:30. So here we go. Here's 3:10. 3:10. We're going from 3:10 to 3:30. In fact, actually, let me put them both on the same one. So here is 3:10 right over there. Here's 3:30 right here. That obviously sweeps out an arc. If you want to, go ahead and put points in there. We'll call that point A. We'll call that point B, right? I've got this arc here, and I want to know what is the measure of that arc A, B. What is the measure of that arc? Okay, here we go. Well, here's what you know. The minute hand, right, to go all the way around a clock, one full rotation, is 60 minutes. 60 minutes equals one rotation. And one rotation is 360 degrees, right? That's all stuff that we know. So 60 minutes is one full rotation, and because it's a circle, one full rotation is 360 degrees. Now, from 3:10 to 3:30 p.m., how many minutes is that, right? If one full rotation is 60 minutes, from 3:10 to 3:30, how many minutes is that? Well, I can't do the simple math. Just count, right? 5, 10, 15. It's 20 minutes. Okay, so my arc is 20 minutes of the full 60 minutes it takes it to go all the way around. So 20 divided by 60, that means that 20 minutes is 1/3 of a rotation. Right? In order to go from 3:10 to 3:30, I've gone 1/3 of the way around a full circle. 20 divided by 60 is 1/3 of a rotation. Well, at this point, you're there, right? I know one full rotation is 360 degrees. So how many degrees is 1/3 of the way? Simple math. 1/3 multiplied by 360 degrees, you wind up getting 120 degrees. So the measure of arc AB is 120 degrees. That is the measure of the arc from 3:10 to 3:30. What we'll do on the next page of the notes is take a look at a few more example problems dealing with central angles and inscribed angles, and I'll meet you guys there.